like I said, if I showed everybody how to do everything, then we'd all get them right, but I don't. So every once in a while, we're going to make a minor mistake. You've started off perfectly. You've taken the sine of both sides, and if you take the sine of the inverse sine, then you get back x. And then you've proven to me that you know the chain rule, because you've taken the derivative of both sides. The derivative of cosine is going to be cosine of the inside times the derivative of the inside equals 1. Everybody with what Ryan's done so far? We good? And then he solves for s prime of x, and he's got that. And his answer is absolutely right. Nobody can argue with him. Absolutely right. I would like to rewrite this completely only in terms of x. Because I'd like, just like if we take a, so I'd like to rewrite this side only in terms of x. So I'm going to show you a trick that's really, really important for things we're going to do in the very near future. I'm going to do the following. I'm going to take your line right here, Ryan, and say, think of s of x is your angle, right? So sine of s of x is the same as x over 1. You with me? You believe that? Now, what's our rule for sine from high school trig? Sine is opposite over hypotenuse, right? So if I draw a triangle here, and this is my angle, s of x, then this must be x, and this must be 1. Now, why am I doing all this? Because I want to figure out what cosine of this angle is, and if I can finish out the triangle, I can find out what cosine is. So now, what's this side?
Square is a 1.
Right? This squared plus this squared has to be this. So whatever this is, a squared plus x squared has to equal 1. So that a squared must be 1 minus x squared. So a must be the square root of 1 minus x squared. And now I know what cosine is, right? What is cosine of s of x equal to? Adjacent over hypotenuse. With me, right? So s prime of x is now 1 over square root of 1 minus x squared. Questions, any of the steps over there? I gotta warn you. Oh, he lost his name. Lovingood, right? Lovingood asked me about this problem, and it reminds me that there's a notation that we use in mathematics that's very, very bad. When we write this, we mean the function that is the inverse sine of x. All three of these are used interchangeably in math and physics and engineering books. They all mean the same thing. And none of them mean 1 over sine of x. Because this means the function that is the inverse of the sine function. And it's a horrible notation, because if we write sine cubed of x, we really do mean sine of x all cubed. But if we write sine negative 1 of x, we don't mean sine of x to the negative 1. We mean the inverse function. So I apologize for the years and years of mathematicians using horrible notation, but that's okay. Who up on? No, you're on integration. We have another derivative back there. Secant inverse. Scorpio, you're up.